In a previous video, we talked about that one way to find the area of a triangle was using that formula that we learned from geometry. Area equals 1/2 times the base of the triangle times the height of the triangle. In that video, we talked about another way to find the area of a triangle, which was 1/2 times the base times, instead of the h, we solved for h and we found that that was the other side times the sine of the included angle. In this video, I'm going to teach you yet another formula. When do you use which one? Well, you use this one if you know the base and the height. You use this one if you know the base and if you know two sides in the included angle, but not the height. And you use the third one, well, I'll show you. I'll start with a generic triangle, and I'll label it the way I like to label my triangles. Angle's there, angle B is there, and angle C is at the top. That means side A, side B, and side C are here. I'm also going to drop a vertical line down from the top angle, at least it's the top angle in terms of the orientation it's currently in, and I'm going to note that that's a right angle. I'm dropping this vertical so that it is a right angle here, so that this line forms a right angle with this one. If I imagine that I've drawn these on a set of axes, I can put a mark here, and I can make the observation that this distance from here all the way to here is C. And that's because the distance, the length of this side is C. The length of this side of the triangle is C. So that's a length of C. I'm going to erase this C because they're the same thing and I need the space. And that means that this point right here, this x coordinate, if you will, is C. If I then take the distance from here to here and call it x, then the distance from here to here is C minus x. If this is x from here to here, then from here to here is the whole thing minus this much. All of C minus x. I'm also going to call the height of the triangle h. Now let's make the observation that x squared plus h squared equals a squared, using the Pythagorean theorem on this small triangle here. This is a right triangle, so I can use the Pythagorean theorem on it. If I subtract h squared from both sides, I get x squared equals a squared minus h squared. And that means, of course, that x is equal to the square root of a squared minus h squared. What I've done is I have found a way to write x. What is x worth? What's another way to express the length x? The answer is the square root of a squared minus h squared. You probably recognize the form of this from the Pythagorean formula. Now let's take a look at this bigger triangle here. From this bigger triangle, I can write the side c minus x squared plus the side h squared equals the hypotenuse b squared. I'm going to do the same thing here and subtract h squared from both sides. So I'm going to get c minus x squared equals b squared minus h squared. Now I'm going to expand the left-hand side. I'll get c squared minus 2cx plus x squared still equals b squared minus h squared. Now I'm going to go back up to these two lines here, this one right here and this one right here, which I will also highlight just so we have it. And I'm going to use this way of expressing x and this way of expressing x squared in this formula. So that gives me c squared minus 2cx, but x is the square root of a squared minus h squared, plus x squared, but x squared is a squared minus h squared, and that's all still equal to b squared minus h squared. Notice that I've got a term minus h squared on both sides, so if I add h squared to both sides, those will disappear. That gives me this version, c squared minus 2c, the square root of a squared minus h squared, plus a squared equals b squared. In the next step, I'm going to move this to the right-hand side. I'm going to add the quantity 2c times the square root to both sides. At the same time, I'm going to subtract the b squared from both sides. So I'll get a squared minus b squared plus c squared equals 2c times the square root of a squared minus h squared. Now at this point, the algebra might get a little bit gnarly, but bear with me. I will not ask you to reproduce this. I just want you to see where this formula comes from. The next thing I'm going to do is square both sides. Squaring the right-hand side isn't too hard. Since ab squared just equals a squared b squared, what that means is that for every factor inside the parentheses, if the whole thing is squared, you just take each individual factor and square it. That's what I'm going to do here, except that I have three factors. I have a 2, a c, and a square root. The 2 needs to get squared, the c needs to get squared, and the square root needs to get squared. So I'm going to have 4c squared times a squared minus h squared. Now, the left-hand side is a trinomial squared, so that would be a squared minus b squared plus c squared times a squared minus b squared plus c squared. As it turns out, we don't need to do anything with that, thank goodness. It can be done, it's pretty messy, but we don't need to worry about it. We're going to use this in this form. That thing squared. My next step is going to be to divide both sides by 4c squared. Now normally I would write this like this, showing that I was going to divide by 4c squared, but I am very quickly running out of room, so I'm not going to do that. I'm just going to show you the result. I hope that your algebra is strong enough. It should be. I'm going to have on the right hand side, I'm just going to have a squared minus h squared. And on the left-hand side, we'll end up with a squared minus b squared plus c squared, all squared, over 4c squared. Now, what I'm trying to do here is isolate the h. So the next thing I'm going to do is subtract a squared from both sides. That's going to give me a squared minus b squared plus c squared, all squared, over 4c squared minus a squared, and I'm going to write that up here for a reason, and that's now equal to negative h squared. And in my next step, what I want to do is combine these two terms, so I need a common denominator here. So this is going to be, in fact, I need to move it over a little bit. A squared, and I'm going to have a 4c squared over 4c squared. All right, now I have a common denominator here, so I can combine these two terms. But notice that here on the right-hand side, I'm getting close to being able to isolate h. So I'd really like for it to be positive. So I'm going to multiply through by negative 1. So multiply both sides by negative 1, which is going to make this term negative, this term positive, and on this side, the only term here will be positive. So when I rewrite this, which I'm going to do over here, I'm going to erase this side and continue on this side, continue over here. I'm going to change the signs from positive to negative, negative to positive, and negative to positive. And at the same time, I'm going to combine these two terms into one fraction. So I'll have positive h squared equals negative a squared b squared c squared all squared over 4c squared plus 4c squared a squared all over 4c squared. So I'm going to reverse the order of those terms as well and have positive 4c squared a squared over 4c squared minus a squared b squared, and so on. And at the same time, I can combine those. So I'm going to have 4c squared a squared minus the quantity a squared minus b squared plus c squared, all squared, and that's all over 4c squared. By this same rule up in the top right-hand corner of the screen, if I have a, b quantity squared, then I can take each factor and square it like this. Or if I have this expression, or an expression that looks like this, I can write it this way, and that's what I'm going to do now. I'm going to take that first term, 4c squared a squared and write it as 2, I think I'll write it as ac all squared. Just a little bit of simplification there, just copying the rest. But now what I see when I look at this is a difference of two squares. I have a squared term here, the thing squared minus another thing squared. The things are not simply, we're not looking at x squared minus 4 here, right? But it is a difference of squares. And so I can write this as in factored form, basically. So let's write this as h squared equals, I'll put my denominator down, and then I'm going to have 2ac plus the quantity a squared minus b squared plus c squared times 2ac minus the quantity a squared minus b squared plus c squared. I was worried that I might not be able to write small enough there to get that all in. Okay, we're making progress, but I need more space. So now I'm going to erase this part of the screen. If you need more time, pause the video. Okay, so we have h squared equals, and I'll go ahead and jot down my denominator, 4c squared. And now I'm going to distribute the plus and the minus in my two factors. So I'll have 2ac plus a squared minus b squared plus c squared, and 2ac minus a squared plus b squared minus c squared. Now, this is a little bit tricky. It means that you have to recognize this pattern. I'll just jot it down here and then I'll erase it. That a minus b, when you square it, gives you a squared minus 2ab plus b squared. So I'm looking for this kind of pattern so that I can factor it as a perfect square binomial. They're not quite in that order yet, so I need to reorder them, but there's that 2ac, that's the 2ab, and there's a 2ac there as well. So I'm going to do this in stages. I'm going to erase my little formula down here. And I'm going to do this in stages because I can do the first one relatively easily, and the second one's going to take a little bit more manipulation. So I'm going to reorder these terms: a squared plus 2ac plus c squared minus b squared, and then that'll be times the other factor, and I'll leave that as it is for now. I'll come back to that one in just a minute. And I'm going to rewrite this first factor as a plus c all squared minus b squared. That's following that pattern here. Let me just write it up here. I'll write it as plus this time. A plus b all squared equals a squared plus 2ab plus b squared. And a minus b squared equals a squared minus 2ab plus b squared. If you just, that was a messy two. If you just FOIL this, if you just write this as a plus b times a plus b and expand it, this is what you'll get. But it's a predictable pattern. So making the observation that those terms are in here and reordering them lets me see that this will factor like this. I'm left with a minus b squared, but that's okay. Now I'm going to do the same thing with the second factor, this factor here. But in this case, it's a little bit tricky because my 2ac is positive, which means it feels like I should be in this situation here. But it's a and c instead of a and b, so I should have an a squared and a c squared. But I have a negative a squared and a negative c squared. If I have a negative 2ab or negative 2ac, then my a squared and my b squared are positive. So the signs are wrong, but consistently wrong for this pattern. I can't do this pattern because I'd have to make all of my terms positive or all of my terms negative. But for this pattern, it seems like all I need to do is change the signs of all of these. So what I'm going to do is reorder them in the same way as I reordered them in this case. But I'm also going to introduce a minus here. So what I'm going to end up with is b squared minus the quantity. Now, because I'm factoring out, my b squared just gets copied down here. I'm factoring out a negative. So I'm factoring a negative out of my a squared. It's going to make it positive in here. Out of my c squared, that's going to make that positive in here. But I'm also factoring a negative out of my 2ac. That's going to make it negative down here. So let's see. And I'm going to write the c squared first. I know the punchline here, so I'm kind of cheating. In the interest of time and space, I forgot a plus there. I have converted this expression here into this form in one step. You know, normally I would take more time and more space to do that, but I don't really have the space. And you don't need to know all the details here. I want you to see, as I said before, I want you to see where this formula came from, but I'm not too concerned that you necessarily be able to reproduce it. Now when I look at this, c squared minus 2ac plus a squared, I see this, a squared minus 2ab plus b squared, which factors like this. So I can rewrite my second factor as b squared minus c minus a all squared. And that is, of course, still over 4c squared. All right, it's time to go grab some more space again, so I'm going to erase this part of the screen. Take a moment to pause the video if you need to. I'm also going to move just a few things around a little bit here so we can grab just even that much more space for our next step. Okay. Now, from here, I notice that inside each of these two factors, I have differences of squares. Again, I have this thing squared minus this thing squared, and this thing squared minus this thing squared. So let's write those out as in their factored form. I have h squared equals a plus c minus b. Well, we could just do plus c, or plus b rather, first, times a plus c minus b. And that is all times another difference of squares. B plus c minus a times b minus c minus a. So again, that's just a different way to write that numerator. And so now I have, I'm removing the parentheses and distributing where that's appropriate. That should have been in parentheses. I have a plus c plus b times a plus c minus b times a negative a. I'll just write it as b plus c minus a. And then the last one is b minus c plus a by distributing that negative over 4c squared. Now I'm going to do just a little bit more reordering. I'm going to write this as a plus b plus c times a plus c minus b times b plus c minus a times a plus b minus c. So all I did here was first I put this version in alphabetical order. And in each of these other versions, I put the positive terms first and the negative term last. It doesn't really matter, but for the next step, I wanted them in that order so that this minus down here was a little bit more obvious. Now I'm going to try to squeeze one more line in on this screen here for erasing the other side to continue. And I want to make the observation that ideally I want these in alphabetical order. I want an A and then a B and then a C. Here I have an A and then a C, but my B is negative, so I've shunted it to the end for the moment. So what I'm going to do is I'm going to add a b in here and then subtract another b. I want an a plus b plus c, and then I'm going to subtract another b. In other words, I'm going to add and subtract b from this factor. So I'll rewrite the first factor, a plus b plus c. A plus b plus c, having added a b, I need to subtract a b, so I'm going to subtract b here, but I already have a minus b, so now I have minus 2b. And I'm going to do the same thing with this next factor, a plus b plus c, but in order to get that positive a, I've had to add an a, so now I need to subtract an a. I can't just randomly add a value without balancing for it somewhere. So if I add an a, I have to subtract an a as well. So I have minus a, so I have minus 2a. I have minus a because I've added an a, so I must subtract an a, and then there's already a minus a there. So now I have minus 2a. And lastly, I have a plus b plus c minus c minus the c that's already there. So this is going to become minus 2c. And I'm going to rewrite it that way. Just keep hoping that if I explain it in different ways, you'll understand one of them. Minus 2c. All of that is still over 4c squared. So again, if you need to pause the video, this would be a good time to do it. I'm going to erase the right-hand side of the screen, and we'll continue there. Before I do, let's do this. I'm going to mark a plus b plus c, a plus b plus c, a plus b plus c. This was what my goal was by doing all of that silly adding and subtracting a b, adding and subtracting a c, right? I wanted this a plus b plus c to show up in all of these factors. And now what I'm going to do is I'm going to say let p equal a plus b plus c. Why p? Well, check this out. A plus b plus c is the perimeter of my triangle. So each one of these, a plus b plus c, is a perimeter. So that means that I can write my formula in its current form as h squared equals p times p minus 2b times p minus 2a times p minus 2c all over 4c squared. It's just a shortcut. It's a shorter way of writing this mess, right? It's a nice shortcut. But if we recognize that we have this commonality, if you will, in all of these factors, then just making the note that p is going to stand in for that sum, then we can just rewrite it. Now, ultimately, I want h. Minus 2a times p minus 2b times p minus 2c, right? And it's going to be the square root of that over the square root of 4c squared. But the square root of 4c squared is 2c. Okay, that was a very long-winded way of finding another way to write h, the height of this triangle. This is a generic triangle, remember, I just happened to have put it into a coordinate system so I could do this work. But now what I'm going to do is I'm going to take this h and I'm going to use it in this version of the area formula. In order to do that, I'm going to have to erase again. So I'm going to erase this part of the screen and probably maybe this line as well, and kind of try to tidy a few things up. And then I'll use the space that I have left to show you what happens when you put this version of h into this formula here. Okay, I need to start by moving a few things around here. So the things that I've retained are the substitution formula, the p equals a plus b plus c. And I need that because I want it to be obvious what p is in my new formula, right? Now, this is a formula for height. I'm looking for a formula for area. So I'm going to rewrite the formula for area. A equals 1/2 base times height. Then I'm going to replace this height with this expression here, right? I'm also going to make an observation here. The way I drew my triangle, my base is labeled C. So I'm also going to replace the B in my area formula with C because that's what my base is labeled with. I did this work here based on this triangle. My base is C. So let's rewrite this again as A equals 1/2 times the base of my triangle times height. And height here is the square root of P times P minus 2A times P minus 2B times P minus 2C all over 2C. And hopefully now you can see why it's important that we label things correctly, right? This C and this C are going to cancel each other out. So let's do that algebra. And then notice that this 1 over 2 and this over 2 here is going to become over 4. So I'll write this as A equals 1 over 4 times the square root of P times P minus 2A times P minus 2B times P minus 2C. And it would be nice, I think, if this 1/4 was inside the square root as well. Actually, I don't really care, but the way the formula is actually written, we're going to need that. So if the 1/4 is outside the square root, then in order to take the square root of something and get 1/4, you have to square it when you put it back in. So this becomes A equals the square root of 1/16 times P minus 2A times P minus 2B times P minus 2C. Now, honestly, if it had been me, I think I'd have left it like that. I know what a perimeter is, right? Even if I didn't, I could say, well, let P equals A plus B plus C, right? I know I can figure out what P is from that and plug P in. But for some reason, the original convener, if you will, of this formula, that wasn't good enough for them. They needed something called a semi-perimeter, which is the perimeter divided by 2. So A plus B plus C divided by 2. And so each of these P's, what we really want is P divided by 2. The good news is that if I take this 1 over 16 and apply 1/4 of it to each of these, I get a P over 2, a P minus 2A over 2, a P minus 2B over 2, and a P minus 2C over 2. So I'm going to rewrite it again. I'm basically breaking this 1/16 up into 4 parts, right? 1/4. It's worth noting that 2 to the power of 4, or 2 times 2 times 2 times 2 is 16. So each of the 4 parts of these is going to be a 2. So that gives me A equals the square root of P over 2 times P minus 2A over 2 times P minus 2B over 2 times P minus 2C over 2. And that's all under my square root. Okay, so now I'm going to rewrite this again as P over 2 times, this is P over 2 minus 2A over 2 times P over 2 minus 2B over 2 times P over 2 minus 2C over 2. And we can reduce these fractions. And at the same time, I'm going to let P over 2 be represented by the letter S. So I'm going to simplify and substitute here. This is going to give me S times S minus A times S minus B times S minus C. And that is called Heron's formula. Let's tidy a few things up and move some things around on the screen. This is going to take me a couple of moves. There we go. And I'll give this a subscript of t as well. These are all the area of a triangle. Sometimes you see that like that. Sometimes you just see A because the context, hopefully, is clear. And you might even see this, the area of a triangle. That's a triangle. I don't know. I like A sub t. Okay, so we now have three formulas for the area of a triangle. The area of a triangle is either 1/2 times the base times the height, or it's 1/2 times the base times the sine of the angle times C, but B and C have to include angle A, all right? Notice that this, if you have an angle A here, then the side opposite it would be A. So these other two sides have to be B and C. So the notation we've used here is consistent with that naming convention, all right? All right, and then we also have this formula for the area of a triangle. It's the square root of s times s minus a times s minus b times s minus c. But what is s, right? We know what a, b, and c are. They're the in context, they're the sides of the triangle. But we need to say where s equals, there's several different ways you could write it. I'm just going to go ahead and write it as a plus b plus c over 2. You could say where S is the semi-perimeter. Perimeter of the triangle. That's a bit wordier, so sometimes you'll see it written that way. Sometimes you'll see it written this way. We don't really talk much about semi-perimeters these days, so I think this one actually makes a bit more sense anyway. At any rate, you now have three formulas for the area of a triangle. One of them requires that you know the height of the triangle. One of them requires that you know two sides and the included angle in that triangle. And one of them only requires that you know all three sides. Literally only requires that you know the lengths of the three sides of the triangle. You don't need to know the height. You don't need to know any of the angles. You just need to know A, B, and C. And you need to know that S is built by basically adding A, B, and C and dividing by 2. Well, that is another record length video, but the good news is that and the first video, the previous video, are the only ones for this section. So we're going to quit there. I know I didn't do any examples here, but it really is just a matter of plugging in some numbers. So we'll probably do a few of these in class. And honestly, you won't see this formula very often. It's just kind of handy to have up your sleeve. Maybe if you're still building your note card, if you're planning on making a new one before the module exam or module challenge set or basic skills test, maybe put the area formulas together on your card. At any rate, that's going to be it for this section, and our next section will be something quite different.